Hello, class 12, again here with the chapter 2. Students, do you know whenever a conductor is placed in an external electric field, then it shows certain properties. Let us learn those properties today under the heading Electrostatic Properties of a Conductor. The first property says that whenever a conductor is placed inside an external electric field, then the electric field inside the conductor must be 0. It means that conductor which is placed in that external electric field, inside that conductor the electric field must be 0. So that can be explained by taking external electric field, positive, negative. This is a conductor and this conductor is having side A, B, C, D. Now due to the presence of this electric field, as electric field is present over here, so due to the presence of electric field, the electrons from the side, they start moving towards the opposite direction of the electric field. So negative charges are induced on the side AB and positive charges, they are induced on this side CD. Now due to these charges, negative charges appeared on this side and the positive charges are induced on the side CD. Due to this, an electric field is induced, E induced, and this electric field is induced in the opposite direction of the external electric field. This process continues till this induced electric field becomes equal to the external electric field. So this is external electric field. So the net electric field, it becomes or it is equal to 0 because these two electric fields, they cancel the effect of each other. So hence the electric field inside the conductor is equal to 0. So according to this, the first property says that the net electrostatic field is 0 in the interior of a conductor. The second property says that just outside the surface of a conductor, the electric field is always normal to the surface. Now if any conductor is there, like we have a conductor over here and we are taking any of the point, like this point over here. So at this point, the direction of the electric field is always normal to the surface of this conductor. Now to prove that, if we say that the direction of the electric field is not normal but it is at some other direction making certain angle with the surface. So in that case, if electric field is along this direction, then electric field is having a non-zero component along the surface and one component along this direction. Now due to this component, non-zero component along the surface, the electrons, they will start moving along the surface and they will produce surface currents, and that is not possible. It means that this fact that we are taking the electric field is along any direction making certain angle with the surface, this fact is totally wrong. So it means that the electric field is always normal to the surface. So the second property says that the electric field is normal to the surface of the conductor. The third property says that the net charge in the interior of a conductor is 0, and if any excess charge is given, then it always resides on the surface of the conductor. So it means that if any conductor is taken and if any excessive charge is given or any charge is given, then this charge always resides on the surface according to the third property, and inside that the electric field is 0. This is according to the property. Now let us prove that. Let us take a Gaussian surface over here inside this conductor. This is a Gaussian surface. Now according to the Gauss theorem, the flux is equal to the charge enclosed divided by epsilon naught, or the electric flux that comes out from this Gaussian surface which is containing some charge Q, it is always equal to 1 upon epsilon naught times the total charge enclosed. Now here in the first property, we have discussed that electric field is 0 inside a conductor. This we have already discussed in the first property, that electric field is always 0 inside a conductor. So we can use that property over here. electric field is 0. If electric field is 0 inside this conductor, then there is no flux which is coming out from this Gaussian surface. This is our Gaussian surface. So as electric field is 0, means if there is no electric field, means there is no flux that will come out from this Gaussian surface. So the value of phi is equal to 0. So 0 is equal to q upon epsilon naught. That gives us charge is equal to 0. It means what? That inside this conductor, that there is no charge present. Hence we can say that the net charge in the interior of a conductor is always 0, and whatever charge is given, that always resides on its surface. Another property related to this conductors when they are placed in electric field is that potential is constant within and on the surface of a conductor. So potential is constant within the surface or on the surface. For that, you have studied about that the electric field is the negative of potential gradient minus dV upon dr. E is equal to minus dV upon dr, that we have already studied in our previous sessions. Now, electric field, the value of the electric field inside the conductor, already studied that electric field is equal to 0. Inside a conductor it is equal to 0. If it is equal to 0, then dV upon dr is equal to 0. Now, differentiation d by dr of a quantity is 0, and this is possible only when V is equal to constant, because you know that the differentiation of that quantity is 0, which is always a constant. Hence we can say V is constant over here, and this is our property. This is the property of a conductor also, that whenever a conductor is placed inside an external electric field, that the potential within the conductor or on the surface is always equal to 0. So these are few properties of the conductors when they are placed inside an external electric field. So all these properties will be given to you in the form of notes in your homework section.